Hi guys, this video is going to be a tutorial showing you how to create a complete 2D game in Godot from start to finish. It's called the minimum viable game because it's pretty much the simplest game I can imagine. But if you watch this whole video, you'll be able to create your own 2D game with Godot. So here's a demonstration of the complete game. We begin on the start screen, which has some animated text. And when we click the start game button, we transition to the game state, which enables us to move around as this object and selects these four pickups. And when we overlap, it plays a sound. It also increments the counter variable. And when that reaches 4, i.e. we've collected all the pickups, we transition to the win screen, letting the player know we've completed the game. In order to get up and running with Godot, simply navigate to godotengine.org and download the latest binary release. Now unzip that folder, and then simply run the executable. Godot does not require installation like other popular game engines. When you run Godot, you'll be presented with the project manager screen, and simply click create to start a new project. And I'd recommend creating a new folder for your Godot games, otherwise it'll just dump them all into your documents folder by default. And also note that Godot will use this kebab case, or hyphenated case, to name your projects. And this can all be changed in the project settings. As for the renderer, unless you want advanced 3D graphics, I would just stick with compatibility, since it enables you to export for desktop, mobile, and web. So you can put a web build on itch.io, for instance. And if you're making a serious project, definitely use version control, but we'll just leave it for now. So before we get working on the game, let's just set things up. I'll go into project settings and I'll change the default window size to 720p. And I'll also enable static typing for GDScript to make the development experience a bit more strict. So if you go under shader language and treat warnings as errors, and then we'll also enable warnings for untyped declarations and invalid declarations. And then open the editor settings and we'll just enable type hints as well. And now instead of dumping everything into this folder, let's create some new subfolders. I'll create one for scenes, one for scripts, one for shaders. We're gonna have a shader. And I'll create an assets folder. And inside the assets folder, I'll create subfolders for images and sounds. And then I will drag the Godot icon into the images folder. Great, now we're ready to develop the game. So where do we start with making the game? First of all, since we're making a 2D game, let's head over to the 2D view. And now we can see the viewport region we've defined. If we click the play button now, there's a pop-up telling us we can't play the game since we never defined a main scene. So let's do that now. Click 2D scene to create a root node, and I'll just call it main. Then I will save this scene as main.tscn in the scenes folder. And now we can run the game using this scene. Now let's add the Godot icon to the game, since this will be a player character. And I'll also adjust the background color in the project settings. And now we have a running game. Okay, now let's get our player character moving around. Luckily, Godot has a built-in controller we can use. So if we add a character body 2D to our scene, we can rename it player. And then make the sprite a child, this node, and we'll also add a collision body, collision shape 2D, and make it a rectangle. And then I'll just zero out the transform on the sprite and stretch the collision body over the player character. And I'll also group these nodes together. And then we can just drag the player back where we would like it. Start. Now if we play the game, you'll see there's no difference. We still can't interact with the game at all. But if we add a script to our player object, make sure to put it in the scripts folder we created. You can see we can leverage the built-in character body 2D basic movement template. And now if we play the game, you see we just fall straight down. So how should we edit this script to get the behavior we want for our game? First of all, I'll remove the gravity and jumping sections since we don't want these. And now if we playtest, see we can move left and right, but not up and down. And that's thanks to the built-in movement callbacks here. Godot does tell us we should replace these UI actions with our custom gameplay actions. So we'll do that now. We will specify, if we go to project settings, some custom input mappings. And I'll call this one move_left. And I'll map this to the left arrow key, as well as the A key. We'll have WSD movement as well as the arrow key movement. Specify move right as right arrow key. And the D key. Move down will be the down arrow key and the S key. Up, the up arrow key, or the W key. Now if you replace UI left with move left, UI right with move right, and we retest, we get the same behavior as before. For this, we can only now move in the X direction. How do we move in the Y direction? Or we can just copy and paste the script and replicate it for the Y-axis. So this would be perhaps direction X, can be direction Y. Change these to the Y-axis as well. We'll call this move up and move down. Fix these full names. And I've seen now we can move left, right, and up and down. But maybe you notice the bug in this implementation. We're actually moving more quickly in the diagonal direction than along any one plane. And that's because we're not normalizing the vector. Now you can do this manually, but Godot actually provides an inbuilt implementation we can use. So instead of the input.getAxis function, we just call the input.getVector function, and we pass in all of our movement vectors. Like so. You see we can now move in all four directions, and we no longer move more quickly diagonally than we do up, down, left, or right. Now we've successfully created a player character, a player controller, and we're moving around the screen. And next we'll add some collisions to the world boundary, so we can't just go out of the screen like this. So in order to constrain the movement to within the viewport, we can just add a bunch of collision meshes and make them children of a static body, which I'll call the walls. and we'll have 4 collision shapes each side. And just size them up. If you'd like to get it exact, you can enable the grid snapping mode. Not really necessary. And I'm just using F2 to rename the nodes quickly. Instead of double clicking. And you see, we now can no longer move outside of the play area. Okay, now let's implement some collectibles. I'll just reuse the Godot icon again to save us finding assets. So if you just drag it into the scene, see we get another Sprite 2D, and we want this at the top level now. And this will be one of our collectibles. To distinguish it from the player icon, let's do a few things. First of all, we will just flip it vertically, yes. And then we'll also add a custom shader just to tint the sprite so we can identify it separate from the player character. And to do that, select the Sprite 2D and scroll down to material. We will add a new shader material, and we will add a new shader, and we will save this in the shaders folder and call it pickup.gd shader. Now this isn't going to be a tutorial about shaders, so I'll just copy one of the examples from the Godot documentation, and you'll see we've now tinted the collectible to be a different color. However, to actually interact with the pickup, we'll need to define it as an area 2D, which rather than a static body allows us to move into this space, but it still detects a collision. So if you add an area 2D node to the scene and call it pickup, and make the sprite a child, and we also need to add a collision body. A rectangle, and I'll just zero out the transform. And then, as before, just stretch the shape over the sprite. Group this up. And move it to where you would like it. Now we just need to add a script to the pickup to define the interactions we want. Make sure to add this to the scripts folder. And in order to do this, we will use the Godot signal system. So select the area 2D of the pickup, and we want the body entered signal. So double click that, and we will connect this to the pickup script with this function. And for now, we can just call Q3, which will remove the object from the game world. So just to test this, we can move over the object, and we see it now disappears. But of course, we would like multiple pickups. So we can simply duplicate the object we've created. And quickly test this. Seems to be functioning as expected. Just to clean this up a little bit, I'm going to group all of these pickups under a single node. So if we just add another node 2D to the scene and call it pickups, we can just nest these underneath. Like so. So in order to keep track of the score in our game, we'll need to declare a counter variable. And I think a good place to do this is in the root node. So we'll add a script to the main node2d up here, placing it in the scripts folder. We can simply declare a variable like this. And we won't be using the process function here, so we can just clean this up. So we don't need the ready order process function pickup, so we can remove it. So essentially we need to increment our score when we overlap with one of the pickups. And a clean way to do this is to make use of a custom signal. So if we head back to our pickup script, we can define a signal called collected, and then on entering the object, we can emit this signal, and then we can listen for it in our main script. If we head back to pickup now, you can see we're emitting this signal. And if we link it up to our main script, we now have a function on pickup collected. And here we can increment our counter. And now we can just print it in the console. See the value. See, it now prints a value of 1, and it started with a value of 0. And we simply need to link up each pickup's collected signal to that function, like so. We don't need to use a new method name. We can actually just use the exact same function and all alias together like this. It's quite a clean solution. So you can see our score now works as intended. Just as a quick aside, since we've been testing the game a lot, it's convenient to have a quick way to exit rather than just pressing the X button every time. So you can just use this code snippet to use the escape key. So if we quickly exit the game. Like so. Now instead of displaying our score in the terminal, it would be nice to display it on the screen. So let's add a label node to the scene. And I'll rename it score. And we can just put some placeholder text on something like selected and however many we have, and what font size, like this. And of course, when we overlap one of the pickups, we want to increment the text. How do we do that? Well, in our main script, we can simply reference this label, this score node, in our onPickUpCollected function. As well, we should initialize the states when we start the game to the default value of 0. And then we can simply increment that when we encounter a pickup. We just have to interpolate value of the counter to a string using this convenience function. And that should be everything that we have to do. So now we have a functioning game loop, but we don't actually have an explicit win state when we've collected all the pickups. So in order to fix that, let's just add a new scene, which we'll use to make the win screen. We'll add a UI node as root, and we name it as win screen. And then let's add a label. Says you win. And make it big enough. Place it where you would like. And you can test well, first of all, we'll save it in the scenes folder. You can test a specific scene by right-click and say, play this scene. Or if you click this button, it will run the current scene. If we head back to our main scene, we just need to transition to the win screen when we select all the pickups. So if we just check for when the value of counter equals 4, like this, and then explicitly transition the scene using this function, that should provide the functionality we need. So instead of jumping straight into the gameplay, I think it would be better to have a start screen. So we'll just create another scene similar to the win screen. I will call this start screen. And we'll save it as start screen. And I'll add a label. With the name of the game. Resize it. And we'll also need a button to start the game. Check how this looks. Of course, the button doesn't do anything yet. We need to link up the press signal from the button onto a script, and we also need to make a script for the start screen, which we'll need to save in the scripts folder, as usual. Now we can link the button signal, the press signal of the button, into the start screen script. And we just want to transition to the main scene. We can copy and paste this function, replacing the win screen with main.pscn. And now we want to change the main scene of our projects to the start screen rather than the main scene. We just do that in the project settings, redefine the main scene like this. And now when we click the play button, we start in the start screen. We click the start game button and we transition to the game state. And now, just to verify the win state also works, we collect all the pickups and we move to the end screen, showing that we've completed the game. Okay, now that we've finished kind of implementing the whole game, let's add some juice to the game to make it a bit more interesting to look at and to play. So one thing I wanted to do was use Godot's tween system to animate something over time. And I'll use it to kind of make the text on the start screen bounce around a little bit to catch some attention. So you can simply implement it like this. On the start screen script in the ready function, we can declare a tween like this. And you notice I use dynamic typing here because it's of type variant, so a bit redundant to declare it explicitly. And we modified the tween property of rotation of the label. And we need to use the degrees to radians function to declare how much we want to rotate and for how long. And you can just copy this version. Of course, feel free to play around with different values and different properties. And that looks something like this. Now to make this loop, you just call tween.setLoops. And now see the text moves around. It doesn't look quite right though. And that's because we need to redeclare the pivot point to be in the midpoint of text. And you can simply do that like this. And now this is kind of the effect that I was going for. I just noticed there's actually an issue with our implementation. You see we have an error here because we're transitioning to a different scene during a physics callback. So we can resolve this by simply making this a deferred call, which will wait for that operation to finish. And then perform that scene switch. See, we now no longer get this error. Of course, another way we can make a game more interesting is to add some sounds. So I've just gone ahead and imported this sound I found we can use for the pickups. So just go ahead and add an audio stream player node to your scene. I'll just call it pickup sound, and we'll reference the free file. And now in the main script, we can simply call the play function on this node. Like this. Maybe you noticed a little bug there. When we get the last collectible, it transitions to the windscreen too quickly for us to hear the pickup sound. And we can resolve this by simply awaiting for the pickup sound to finish. And that also enables us to remove this pull deferred. And now everything works perfectly. Now that we've completed the game, the final step is to export. So simply navigate to Project Export, and I'll export for Microsoft Windows. And simply export into the game folder itself. And now all we have to do is run this executable, which will open the game. Yeah, so that about wraps up the tutorial, guys. I hope you found it useful. If you've watched this whole video and you still don't feel confident enough to move on to developing your own game, maybe you could try extending this project. For instance, you could add some background music, or maybe you could add like an image background here to make it more interesting to look at. Or maybe you could even try making the game world bigger than just a viewport, right? You could put some pickups over here, for instance, and you would have to figure out a way to like scroll the screen when you move across to keep track of where the player is and have a camera and everything. That'd be a more interesting extension. I plan on making more tutorials for Godot and more complex, interesting projects. So if you found this video useful and you want to see more content similar to this, feel free to subscribe. Thank you.